Hi there! It is now time to start working on the next component of the Theremin V.2, the volume control unit. To simplify the design of this unit, I split it into a number of different blocks, each one with its own specific functionality. Today, we will talk about these blocks and how they interact with each other to provide the necessary sound dynamics that make the theremin a usable musical instrument. But, before diving into the details, please take a moment to subscribe to this channel and to click on the bell to receive notifications when new videos become available. The subscription will also help in making this channel grow and serve you better. Let's begin. The first block, going from left to right, is the volume variable oscillator, which is the block that provides the signal for the rest of the controller's circuitry. The oscillator emits a sine wave of around 400 kHz. An antenna connected to the oscillating tank provides a variable capacitance to slightly change the frequency when a hand is moved in proximity of the antenna. In particular, similarly to what we saw for the pitch variable oscillator, a hand closer to the antenna increases its capacity and lowers the oscillator frequency. Moving the hand away from the antenna, the capacity decreases, causing the oscillator to work at a higher frequency. The output of the volume variable oscillator goes directly to the input of a low-pass filter, which provides a signal similar to the one at its input, but on a different amplitude. In fact, the low-pass filter is centered at a frequency of around 250 kHz, lower than the frequency of the oscillator. In this region of the filter characteristics, a slightly change in frequency causes an ample change in the amplitude of the signal. Therefore, when the frequency of the oscillator changes, the amplitude of the sine wave at the output of the filter will change too. In particular, when the frequency increases, we will go deeper into the cutting region of the filter and the amplitude of the signal will diminish. On the other hand, if we lower the frequency of the oscillator signal, we will come out of the cutting region of the filter and the signal amplitude will increase. The amplitude of the signal is what we want to use to control the volume of the theremin. To do so, we need a way to evaluate the amplitude of the sine wave coming out of the low-pass filter, and this is accomplished by the Peak Detector. The Peak Detector takes the sine wave coming out from the filter as its input and provides a DC signal at its output that is proportional to the amplitude of the sine wave. So basically, when the frequency of the oscillator increases, the amplitude at the output of the low-pass filter decreases, and therefore the DC signal at the output of the Peak Detector decreases too. Conversely, when the frequency of the volume variable oscillator decreases, the amplitude of the output of the filter increases, and so does the level of the DC signal at the output of the Peak Detector. So now we have a DC signal that we can use to control the volume of the theremin. However, this signal is not in the range of levels that is needed to accomplish this task, and so we put, right after the Peak Detector, a voltage range adjuster, which modifies the range of voltages coming out of the Peak Detector to the level necessary to control the volume in the last stage. And finally, here is the last stage. This is a voltage-controlled attenuator with two inputs. The input on the left is used to bring in the control voltage, while the input on the top of the box is used to bring in the sound coming from the audio generator of the theremin. The voltage-controlled attenuator has a vast range of attenuation of the audio signal as its upper input. It is capable, in fact, of letting the signal pass through without any change, but it is also able to totally block it, practically muting the theremin. It is this stage of the volume controller that provides the dynamics to the theremin sound. So, summarizing, we have a variable oscillator that adjusts its frequency based on the distance of the player left hand from the volume antenna. The sine wave coming out of the oscillator goes to the low-pass filter, which modifies the amplitude of the sine wave based on the frequency of the wave itself. The sine wave goes then to the Peak Detector, which outputs a DC signal which has an amplitude that is equal to the one of the sine wave coming out of the low-pass filter. This DC signal from the Peak Detector enters the voltage range adjuster, which adapts the range of the DC signal to the range required by the last stage, which is the voltage-controlled attenuator. This attenuates the signal coming from the audio generator based on the amplitude of the signal coming from the previous stage, and so the amplitude of the Theremin audio is adjusted based on the distance of the left hand of the player from the volume antenna. Starting with the next Theremin episode, we will start analyzing the internal design of each of these blocks, and we will test them in lab. We will work first on the low-pass filter and then on the others one by one. Stay tuned! Thank you for watching this video, and don't forget to give it a thumb up, which will greatly help improve its visibility so others can enjoy it too. Also, if you have not subscribed to the channel yet, please do so to help making more and better videos. And talking about help, a smaller monetary contribution can help too. There are a couple of options that you can choose from. One is Patreon and the other is PayPal. Both are listed in the video description below. See you in the next video, and as usual, happy experiments!